Hello there. Here I am doing question 27. There's a unit square. It's going to be transformed in two ways. Firstly, a dilation factor 2 in the x direction, then a shear by factor 3 also in the x direction. Of course, we've got to illustrate it, and we then have to find the composite transformation. So here we go. I'll start off with illustrating for the first one. So first I'll just draw my picture of the unit square. So 1 0 0 1, and that's at 1 1. Now, if we have to put some x and y's in. After the first transformation, we just have a dilation by a factor of 2 in the x direction, so that's pretty straightforward. That just goes there to 2. Everything just goes 2 in the x direction. It'll be then 2, and that will still be there at 0. So we'll have that. That's the first thing. Now the second thing is the shear. Now, quite likely that will be not at all obvious to you what happens with the shear. So I'll rather than just write down what it comes to, I'll do a bit of working to show how you would work out where it ends up. So here we go. So I've done the first one, no problem. First was a dilation factor 2 in the x direction, so that's that matrix, and that gave you the second one. Now I'm going to do the shear. You can use your formula sheet. Factor 3 in the x direction will be there. The 3 goes in the top right. If it was the y direction, the 3 would be in the bottom left, and there'd be a 0 up in the top right. So there's a shear transformation. Now, what happens to those points? Where do they end up? Well, fortunately, we can use some matrix multiplication to find out, unless you're very familiar with shears. And shears are strange things, so you want to probably first do a bit of multiplying to find out what happens. And because I'm actually going to do it on all 4 points, so I'm also going to include the point 0 0. And I'm going to do it on all 4 points to see where all 4 points of that what is now a rectangle end up. So let's put the points in. There's 0 0. Then I've got 2 0. Then I've got 0 1. And then I've got 2 1. And when you write the points down, the transformation goes across, but the points go down. And we can see where that ends up, and that'll tell us what that transformation does. So here we go. Let's just multiply that out. For the first one, 1 times 0 and 3 times 0 gives me 0. Then I get 1 times 2 and 3 times 0, so that's 2. Then I get 1 times 0 and 3 times 1, that gives me 3. 1 times 2 is 2, and 3 times 1 is 3, so that gives me 5. So I got that for my first row. Then multiplying the bottom row across 0, that's going to give me 0 again. That will give me 0 again. Okay. And then I'm going to get 0 and 1. And then I'm going to get 0 and 1. Okay. Well, there's my 4 points now. I've still got the 0 0. Then I've got 2 0. So that stayed in the same place. That's 2 0. So the ones on the x-axis stay the same under a shear. They always do if you're going a shear in the x direction. The x-axis ones don't move. Then I've got to 3 1. So 3 will be there, 1's up there. So that's 3 1. And then I've got 5 1. So 3 4 5 about up here. Not to scale, of course, but anyway, something like that. 5 1 will be about there. And my shear will look like that. Okay, well that's I think all I had to do was do that. I didn't do the dilation bit because the dilation is very straightforward. But I did do the shear, and you can see where it ends up. It's probably not a particularly elegant picture, but anyway, you get the idea. Now, part 2, find the composite linear transformation. Okay, well remember, what we got here is the thing that we do first is the 2 0 0 1. And that acts on our source. Then the thing that we do second comes to the left of that. 1 3 0 1. And because order is important with multiplication. So that's the first thing we do, that's the second, and if there was a third, that would be to the left, and so on and so on. So this here, this is the composite transformation. So I just have to multiply those to find what the composite is. That's going to give me 1 times 2 is 2, and 3 is 0, so that's 2. 1 times 0, that's 3. And the bottom, 0 times 2 and 0, that's 0, and that's 1. So there's the composite. So if I call that T, is the composite transformation. And to write that out as a linear transformation, then T would take xy to, get that every now and then, this funny straight line, I don't know what it is. I'll have to find out how to stop it. Right, back to there, takes the xy. Now remember, we get ax plus by, cx plus dy, so we get 2x plus 3y, and then just y. And that is the composite transformation. And that is question 27. I'll stop.